Hello everyone, welcome back to this Unity tutorial series on how to create a roguelike like Vampire Survivors. One of the most important features, if not the most important in Vampire Survivors, is the spawning of enemies. Not only does it have a unique style to it that makes it very engaging when playing the game, you could say that the entire game also just revolves around the system at hand. However, as you might have anticipated already, similar to the other things that we covered in this series, the system is not as straightforward as it appears. So what I mean by this is that although it does look like a simple spawning system that raises the difficulty over time, a lot of steps need to be taken to ensure that the system is scalable and customizable enough so that you will have the same flair as the one in Vampire Survivors. So in this part, we will dive into the intricate enemy spawning system of Vampire Survivors and work to recreate the captivating experience in our game. And by the end of this part, you should have something like this, which is an enemy spawning system. You have the different inspector variables here that you can set, which is the amount of enemies, the enemies types, the time, the interval, and yeah, we'll do some improvements to it as well. And without further ado, let's begin. First up, let's begin by determining the structure of the spawning system. So before we begin with any code, it is important for us to take a step back and have a clear idea on how we plan to craft the system. This is especially important with the enemy spawner as it can be extremely complex. So if you take a look at the enemy page on the Vampire Survivors wiki, you'll see that it describes the spawning of enemies as follows. Disregarding the last point about spawning bosses and map events, we can just summarize that the spawning system operates in waves that appear every single minute. And if we infer further, we can also deduce that each wave will continuously spawn one enemy of each type, meaning that there can actually be more than one type of enemy for each wave. To start developing the spawning system, we will first establish a basic class structure, then we will gradually enhance it with added features. To begin, we will create a new C# script named enemy spawner. And within the script, we will create a nested class known as wave to store all the necessary data for a wave of enemies. Inside the wave class, let's define some data for the class to hold. First will be a public string called wave name used to define the name of the wave. Next will be a public int called wave quota used to define the total number of enemies to spawn within the wave. Third will be a public float called spawn interval used to define the interval at which to spawn the enemies. And last but not least, fourth will be a public float called spawn count used to define the number of enemies already spawned in this wave. So be sure to mark the wave class with the system.serializable attribute in order for it to appear within the inspector. Now, as you can see, I put some descriptive comments beside the variables. This is just to ensure clarity, as the complexity of the system is bound to result in a surplus of variables, and with that, some of the variables may be understood and you may end up making careless mistakes if you don't pay attention. Thus, to minimize confusion and misinterpretation, it's important for us to just label the variables appropriately so that we can know how to use them and what they are being used for. Now, you might be wondering why we didn't just define a variable for an enemy prefab in the wave class. Now this is because of our previous analysis of the spawning system in Vampire Survivors, which basically just indicated the possibility of multiple enemy types in a single wave. Thus, it is better for us to just create a list of type GameObject to accommodate the multiple enemy prefabs. Next, we also need to define the enemy's name and respective count. To do this, we can also create lists to contain them. Let's also define a list of the wave class called waves in order to control all the variables we just created from the inspector. Once that's done, head back into the editor and into the game scene. Create an empty game object called enemy spawner and reset its transform. Then, simply add the enemy spawner onto the newly created game object and expand the waves list. If you create a new element and expand it, you should have something like this. So if you're still a bit confused as to how this works, allow me to explain a little. Basically, in order to define a new enemy type for each wave, we have to create a new element for the enemy prefabs, enemy name, and enemy count lists. This means that each element in the enemy prefabs list corresponds with the same index in the enemy name and enemy count list, and vice versa. So I'll just give you an example. For instance, an element with an index of 0 in the enemy prefabs list will correspond to an element with an index of 0 in the enemy name and enemy count list. However, as you might have realized already, although this is a completely justified way of doing things, it gets tedious and confusing very quickly. For example, if you want to add more information about each enemy type, such as the variable to control their starting health, you would just have to add another list and a new element to that list. So if you continue doing that, this leads to a bigger issue of it being very fragile, as you have to keep track of the corresponding indexes and any misassignment or oversight that can break the entire system. So it is very brittle, so I suggest we use a different system. So to avoid these problems, we should go back to the enemy spawner script and make some changes. Luckily for us, there is a better alternative to do things. We can simplify the process by creating another nested class that manages the different enemy types within a wave. To get started, create a new nested class called enemy group, which will define a type of enemy. This class should contain a public string called enemy name to define the name of the enemy, a public int called enemy count used to define the number of enemies of this type to spawn in this wave, and then a public int called spawn count to define the number of enemies of this type already spawned in this wave, and last but not least, a public game object called enemy prefab to serve as a reference to the, enemy prefab. Do make sure that the class is also marked with system.serializable as well. By doing this, we can also remove the 3 lists that we created previously relating to the enemies in the waves class, and add a new list of type enemy group called enemy groups within the wave class instead. Now, let's go back into our editor and examine the changes. As you can see, the enemy groups list stores the information about different enemy groups that will appear in a wave. We can add more elements to this list to define additional enemy groups. This way, we can manage the different enemy types in the wave more efficiently and in a centralized manner, which reduces the setup process and preventing careless mistakes. Great, now we have our class structure set up. Now it's time to get into the main part of the spawning system. Before we start spawning the enemies, we first have to do a couple of things. The first of which is creating a variable to control and view the current index of waves. We can name it current wave count. Do remember that a list starts from 0, this is very important, which means that the count at the start will be 0. The second thing we have to do is to calculate the wave quota variable once a wave begins. This will allow us to know exactly how many enemies will spawn in the wave. In doing so, we don't have to expand every individual enemy group and calculate their spawn count. First, let's create a new function called calculate wave quota. And within this function, we'll basically just initialize a local int variable called current wave quota to 0. This resets the value each time the function is called. Next, we'll use a for each loop to go through all the enemy groups in the current wave count element of the waves array. Afterwards, for each iteration, we will add the enemy count of the current enemy group to current wave quota. This accumulates the total number of enemies that will spawn in the wave. Finally, we will set the wave quota of the current wave count element in the waves array to the current wave quota. So let's test it out. Add a debug.log warning to log the value of the current wave quota and make sure everything is working properly. Then call the calculate wave quota method in the start function. Now head back into the editor and assign the variables like so. When you play the game and look towards your console, you should see the log showing up. Make sure the number shown adds up to the total amount of enemies you just set. If it does, great. Now we can move on to spawning the enemies. Inside the enemy spawner script, create a new method called spawn enemies. Within the script, we first have to create several checks. First, we have to check if the minimum number of enemies in the current wave has been spawned. This is done by comparing waves current wave count dot spawn count to waves current wave count dot wave quota. If the minimum number of enemies in the current wave has not been spawned, the function continues to execute. So what this means is that essentially if the maximum amount of enemies that can be spawned are not spawned yet, the function will just continue to run until it reaches the maximum. Next, a for each loop will be used to loop over each enemy group in the waves current wave count dot enemy groups. And within this loop, the function will just check if the minimum number of enemies of this type have been spawned by comparing the enemy group dot spawn count to enemy group dot enemy count. So if the minimum number of enemies of this type has not been spawned, the function continues to execute. This is similar to the check that was performed for the wave quota in the first step. Now, we can determine the spawning position of the enemy. First, we'll create a reference to the player's transform so that we can constantly keep tabs on their location. Then, to make the spawn position more dynamic, we'll add some randomness by generating a random x and y coordinates and storing them in a vector 2. But that's not all. To ensure that the enemies spawn relative to the player's movements, we'll add the player's x and y positions to the randomized coordinates such that they are relative. And yeah, there we go. The enemy is ready to be spawned based on the updated vector 2 of the player's location. Don't forget to keep track of the number of enemies spawned by incrementing both the enemy group.spawn count and waves current wave count.spawn count as well, as this is very important. Now, although we are not done with the spawning component yet, we can still test out if the method works by calling it in start. Head back into your editor, and before you hit play, let's create a new enemy in order to test the spawning of different enemy types. Head into your enemies folder under prefabs folder and duplicate the bat enemy. Name the bat enemy red bat and change the tint of the sprite to red using the color setting on the sprite render component. That way, we'll be able to distinguish between the two enemies. You can also go ahead and create a new scriptable object for the bat and assign it. I want the red bat to have the same amount of health and deal the same amount of damage as the bat but move a bit faster, so I'll just set the speed to be 3. For a seamless testing experience, it's crucial that you set both the enemy's damage to 0 and temporarily disable their movement scripts. This way, you won't encounter any unexpected issues with the player's health dropping to 0 or the enemies moving around, which will distract you from where they spawn. I'll keep these settings intact throughout the entire part, and I encourage you to do the same, but you don't have to do it if you don't want to. And if you choose to do so, don't worry, I'll provide a reminder before we wrap up to reset the damage and reactivate the enemy's movements. Now, go ahead and set your enemy spawner fields to look something like this. When you hit play, you should be able to see that a single bat and red bat spawn immediately. This means that we have accomplished our goal of spawning one enemy of each type. And if you look towards the inspector, you should be able to see that the spawn count of each respective enemy goes up when their respective enemy is spawned. Great! We're not quite done yet. As you may have noticed, the enemies are only appearing once. This is because we haven't created a continuous call for the spawn enemies function yet. To fix this, let's head back into the enemy spawner script. We'll start by creating a float called spawn timer. This will basically just determine when the next batch of enemies should appear. Next, within the update function, we'll keep the action going by incrementing the spawn timer by time.delta-time, so it just increases based on the passing time, and checking if the spawn timer is greater than or equals to wave's current wave count.spawn interval. So if it is, we'll just reset the spawn timer to 0, and then call the spawn enemies method to bring on the next wave of enemies. So this basically just loops it over and over and over. Now do make sure to remove the spawn enemies in the start function as we no longer need it. For now, head back into your editor and set the spawn interval of the wave to be something like 3. And when you hit play to test, you'll witness one enemy of each type spawning every 3 seconds. And if you wait for a while, you should see that on the third cycle, only a single bat spawns. This is because the amount of bats is set to 3 and the amount of red bats is set to 2. Meaning that during the third cycle, only a single bat spawns since the quota of the other enemy has already been met. Awesome! Let us tackle one more task before we move on. So if you now add a new wave in Play the Game, you'll observe that once all the enemies in the first wave appear, there's a standstill, and no enemies from the second wave spawn. So this occurs because we haven't established a system to progress to the next wave. So we must construct a system to make this happen, more precisely spawning waves at specific intervals of time. As we previously discussed, Vampire Survivors spawning system is designed to release new waves every minute. So let's get right into it and implement this dynamic behavior. Inside the enemy spawner, we will first have to create a new public float variable to determine the interval between each wave like we did for the spawn interval previously. We'll call this wave interval. Afterwards, we'll create a call routine. If you do not know what Unity call routines are, they are basically a way of writing asynchronous code in Unity. They can be paused and resumed, making them a useful tool for writing complex, time-based logic in Unity. And using these time-based properties, we'll be using them to create our time-based waves. For more information on Unity call routines, you can check out Unity's official guide on them. Just like how we define a function in Unity using void, to define a call routine, we have to use IEnumerator. So I know it may sound weird at first, but yeah, I promise you'll get used to it the more you use it. So inside this call routine, we want to do a couple of things. First, we want to wait for a specific amount of time before we execute this call routine. This is done by using uReturnUwait for seconds, which basically just pauses the execution of a coroutine for a defined amount of seconds. And after the wait, we just have to check if current wave count is less than waves.count minus 1. This means that there are more waves to start after the current wave. If there are no more waves to start, the coroutine ends. We are using the waves.count minus 1 instead of waves.count to avoid going out of bounds. This is because, as I said previously, lists start from an index of 0. So for instance, if the count of waves you have is 5, that means that you have a collection of waves going from 0 to 4. Thus, we reduce the count by 1 in order to match with our index. So if the condition is true, the current wave count should be incremented by 1 to signify a new wave, and the method calculate wave quota is called. We're not done yet. As with regular functions, we naturally also need to call the coroutine in order to run it. Inside the update function, let's perform a check to see if the current wave has ended and the next wave should start. If you're still unsure as to how this entire thing works, allow me to explain. Basically, the script contains two main systems, spawning enemies and moving on to the next wave. The begin next wave and spawn enemies function work together in a loop to manage the waves of enemies that appear in the game. Spawn enemies is called by an if statement in the update function which runs continuously during gameplay. This function will continuously spawn enemies of the wave until the wave's quota of enemies has been reached. Now at the same time, the spawn count of the current wave is set to 0 at the start of each wave. So this allows the current wave count if statement in the update function to run, which in turn runs the coroutine begin next wave. Begin next wave is responsible for checking if there is a next wave, and if there is, it will wait for the specified wave interval time to pass before incrementing the current wave count and beginning the next wave. So once the current wave count is incremented, it will start a new wave. Since the spawn enemies function spawns the enemies based on the current wave count, enemies of a new wave will begin to spawn. Additionally, since this is a new wave, the spawn count of the current wave should be 0, which will once again allow the current wave count if statement in the update function to run the begin next wave coroutine, thus beginning the next wave after a specified time. So as you can see, this continuous loop of begin next wave and spawn enemies is what creates the progression of waves in the game, with each wave starting once the previous one has ended. With that said, let's head back into the editor to test our newly made system. Set your spawner to have a similar setting to mine. Now, when you start the game, you'll notice that the red bats start spawning after 3 seconds as part of wave 2, indicating that our wave transition is working correctly. Now, to ensure that the interval system is also working correctly, we will set the enemy count of bats in wave 1 to 5. After playing, you'll still observe that the red bats start spawning after 3 seconds, and the bats will stop spawning, showing that the wave progresses after the time interval has passed and not after all enemies have been spawned. Awesome! Now that we have our base script set up, it's time for us to make some improvements. To enhance gameplay, we are limiting the number of enemies that can be on the map simultaneously. When the enemy count reaches its peak, we'll halt the enemy spawning, regardless of the current wave. So once the number of enemies drops below the maximum due to death, despawning will resume. To do so, we have to start by creating the following variables. First up is enemies alive to track the amount of enemies on the field. Then is max enemies allowed to determine the maximum amount of enemies allowed on the map at once. And last but not least is max enemies reached, which is a flag to indicate if the maximum amount of enemies has been reached. Our next step is to control the number of enemies spawned by going into the spawn enemies method. Now before spawning any enemies, we'll need to check if the number of enemies alive has reached or exceeded the max enemies allowed. If that's the case, we should set the max enemies reach flag to true and cease enemy spawning by returning immediately. Additionally, don't forget to increase the enemies alive count after spawning each enemy. So this is very important, so be sure to remember to increase it. You may wonder why we didn't place this code at the beginning of the method, as it could make the code more efficient and reduce unnecessary checks. However, these checks are actually important and prevent potential issues. So, for example, imagine if you have two enemy types, bat and red bat, each with a count of 2 for a total of 4 enemies. So if the maximum allowed enemies is set to be 3, the spawn enemies method will stop spawning once it reaches 4 instead of 3. So why is that? This is because the method spawns one of each enemy type, and these checks ensure that the correct number of enemies are spawned. However, there is a way that we can reduce the number of checks and enhance optimization, and that way is to implement an additional check at the beginning of the method that checks if the max enemies reach flag is activated. So if it is activated, then it won't run all these checks. This will minimize the subsequent checks after the enemies have initially reached the maximum limit. So once it reaches the maximum, then the next one will stop checking. At the end of the method, we also have to reset the max enemies reach flag if the number of enemies falls below the maximum to resume spawning. And we also have to create a new method called onEnemyKilled, which will be called by the enemy when it dies to decrement the amount of enemies alive. Before we begin testing, head into the enemy stat script and create a onDestroy method. In here, simply reference the spawner and call the onEnemyKilled method here. That way, when the enemy dies, the enemies alive will be decremented. Return to your editor and configure the initial number of enemies in the first wave to be 5 and the maximum number of allowed enemies to 4. To begin the game, start from the menu scene since we need to defeat the enemies. And when you launch the game, the number of enemies present should reach the maximum limit, and the enemies alive count will increase in the inspector. Once you eliminate an enemy, the enemies alive count should decrease and the enemy spawning process will resume. Awesome! One more improvement we will make is spawning the enemies outside of the player screen. Now, to make the game more seamless, we are going to change the way the enemies spawn in the game. So currently, if you notice, the enemies appear randomly within the player's view. But in Vampire Survivors, the enemies actually spawn outside of the player's view for a smoother experience. So to achieve this, we're just going to switch from randomly calculating a spawn position using a vector 2 to a list of preset spawn points. This is similar to the ones that we use for the prop locations in the map generation. This new approach is easier to implement and requires less time and effort. To get started, we want to create a list of transforms to store all the spawn points of enemies. Then all we have to do is select one of these points at random when instantiating and also make it relative to the player's location by adding the position of the player to it. Before we proceed, I just want to mention that there are various methods you can use to implement the enemy spawning in the system. So besides the points, you could also just use the randomly generated points if you just want it to appear randomly on the screen. That's fine as well. Or if you have a different approach that you prefer, feel free to just use that instead. Now let's move on and create some spawn points. In your editor, under the enemy spawner, create a empty game object and name it spawn point. You can also assign a icon to it, similar to the prop locations. And duplicate the spawn point and place them outside of the player's view, making sure to distribute them evenly around all sides for a balanced spawning experience. And at the end, you should have something like this. Next, drag all these points into the relative spawn position field and hit play from the menu scene. You'll notice that the enemies are now spawning exactly on the points that you set up, and if you move around the screen, you'll see that the enemies continue to spawn relative to the player's position and outside of the player's screen. This ensures that the enemies are always spawning outside of the player's view for a seamless experience. Great! The final section of this part we will cover is enemy despawning. Despawning isn't entirely accurate. So rather than completely destroying them, we need to find a way to move them to an appropriate spawning location. So this is important for two reasons. Firstly, destroying the enemies would basically activate the on-destroy method in both the drop rate manager and enemy stats, which would result in the spawning of items and decrease in the number of active enemies, neither of which is desirable. Secondly, and perhaps more significantly, it is crucial to keep the game fair. Just think about it for a second. If a boss appeared on the map and moved towards the player could just simply move away and despawn the boss, which basically just makes the entire purpose of the boss pointless. And now with that said, let's begin by declaring a new float variable called despawn distance within the enemy stat script and set it to be public. This variable is utilized to control the despawn distance, as some enemies may have different distances based on their speed. So there's no need to create this variable in the enemy scriptable object, as it probably won't be altered once the game starts, but you can do so if you want to. So in the update function, we will check if the distance to the player is greater than our despawn distance. If it is, we will return the enemy back using a separate function. To accomplish this, we will create a new function called returnEnemy, and in it, reference the enemy spawner script and move the enemy to a random spawn location by utilizing the following code. Once that's done, head back into the editor and set the despawn distance if you didn't do so already. And afterwards, press play from the menu scene and start moving around. You'll notice that enemies outside of the player's range move back to a random spawn position. Great! Before we end off, here is your reminder to enable both the enemy's movement scripts and damage as well. That's all for this part. In this part, we went through how to create an enemy spawning system similar to the one seen in Vampire Survivors.
I hope you all enjoyed the video, and if you want to support what we do, you can actually help us by becoming a Patreon. This will give you access to the project files for tutorials, like this one, as well as any Patreon exclusive posts on our blog. You can find the link to this in the description below. Any support that you give us will actually go a long way, because currently we are making back about 20 cents for every single dollar that we put into content creation. So your help will actually go a long way to help us make this a sustainable endeavor. So that's all. I'll see you all in the next part. Bye!